Hi everybody. We're going to do a few more trig identities here, and this is basically a review. This is our first one, and this is very simple. Since I have cosine squared on this side and I don't have a sine on my right side here, I'm going to change this to 1. I'm going to substitute this with 1 minus cosine squared of theta. And so I'm going to do that now. And what I'm going to do is distribute and clean it up. And what happens is we have 4 of these minus 3 of those is 1 of those. So that's just 1. So I'm going to write that first because that's what we have here first. 3 plus 1 of those. And this equals the other side. And just substitute it with my Pythagorean identities. Okay, the next one is very similar. We have 4 sine squared of theta plus 2 cosine squared of theta equals 4 minus 2 cosine squared of theta. Again, this side only has cosine squared and we have a sine. So I'm going to use substitute with my Pythagorean identities and change this to cosine squared of theta. Distribute. Now this is like saying 4 minus 4x squared plus 2x squared. If I let x be cosine of theta. And when you combine these two, you get 4 minus 2x squared. My x was cosine, so you get 4 minus 2 cosine squared of theta, which is what we wanted here. Okay, the next one we have is cosecant of theta over 1 plus cosecant of theta equals 1 minus sine of theta over cosine squared of theta. And you can work on either side. I'm going to go ahead and work on the left side here and write cosecant in terms of sine using my reciprocal identities. And I'm going to write this again. Now, for my denominator, I'm going to write this as sine of theta and cross, and you're going to get sine of theta plus 1. What happens here is these can cancel, and you have 1 over, and I'm going to go ahead and rearrange this. It's 1 plus sine of theta. Now, this is supposed to equal this, and it doesn't look like that, so I'm going to force it to look like that by multiplying the numerator by 1 minus sine of theta. And if I multiply the numerator by 1 minus sine of theta, I'm also going to multiply the denominator by 1 minus sine of theta. Now the numerator, we get 1 minus sine of theta, which is what we wanted. And the denominator is this a plus b times a minus b, which equals a squared minus b squared, which gives me 1 minus sine squared of theta. And I know 1 minus sine squared of theta is cosine squared of theta. So we do have 1 minus sine of theta over cosine squared of theta. Now in this one we had squared. We had to force this to look like that. Okay, the next one, I have sine squared of theta over 1 minus cosine of theta equals 1 plus secant of theta over secant of theta. Now, in this case, I think I'm going to go ahead and do like I did last time, but I'm going to go ahead and work on the left side. This is 1 plus 1 over cosine over 1 over cosine. And if I get the common denominator here, this is going to be cosine theta plus 1 over cosine of theta. Now these two cancel. So I have, I'm going to go ahead and rearrange this. 1 plus cosine of theta over 1. Now what I'm going to do, maybe I should just write it over here. Okay, so I'm going to write it over here. Cosine of theta plus 1, and I wanted to rearrange that, didn't I? Okay, so 1 plus cosine of theta over 1. And it has to look like this. So I'm going to go ahead and multiply the denominator by 1 minus cosine of theta. Since I did the denominator, I also have to multiply the numerator by that. When you multiply across, you can get 1 minus cosine squared of theta over 1 minus cosine of theta. We know this equals sine squared. So we get sine squared of theta over 1 minus cosine of theta. Okay. The next one we have is cosine of theta over cosine of theta minus sine of theta. And this is supposed to equal 1 over 1 minus tan of theta. Now what I notice, anytime I have something like this, and I see these two 1s, and I see these two cosines, what I'm going to do is go ahead, you can either say multiply by 1 over cosine. What I'm going to do is just divide everything by cosine. So I'm going to take this cosine of theta, divide it by cosine of theta, over cosine of theta minus sine of theta, and I'm going to divide everything by cosine of theta. Now this equals 1, this equals 1, and this equals tan. So we matched it up and established the identity. Okay, and the last one I have is this one, sine of theta over 1 plus cosine of theta equals 1 plus, doesn't equal, it means plus 1 plus cosine of theta over sine of theta, and this equals 2 cosecant of theta. Now what we want to know is this is really 2 over sine of theta. So just keep that in mind, what that looks like. I'm going to go ahead and take this, get my common denominator, which is 1 plus cosine of theta times sine of theta. And I'm going to go ahead and cross here. I get sine squared of theta plus 1 plus cosine of theta squared. Now I know that this part here is this a plus b squared form, which is a squared plus 2ab plus b squared. So I'm going to write that out. Sine squared of theta plus, now I'm going to write this part out. 1 is my a plus 2 cosine of theta plus cosine squared of theta. I'm going to keep working on my numerator, and I'm just going to write LCD, or least common denominator. We have these two here, that equals 1. So 1 plus 1 is 2. So you have 2 plus 2 cosine of theta over your LCD. I'm going to go ahead and factor out a 2. You get 1 plus cosine of theta. Go ahead and write down your common denominator. 1 plus cosine of theta times sine of theta. Now these cross out, cancel out, and that gives you 2 over sine of theta, which is what we wanted, which equals 2 cosecant of theta. And that's all. Thank you. Have a nice day. Bye-bye.